Hi, I'm Larry Puckett, the DCC guy. Today I want to take a few minutes at the beginning of this video to give you some feedback on the previous videos where we looked at sharing sound decoders and sharing power pickups between locomotives. And then we'll go ahead and take a look at this question of the potential problems that you might run into if you have separate blocks on your model railroad. So let's go ahead and get started. But first, let me remind you one more time, hit that little red subscribe button, and when the little bell comes up, click on it and click all. Thanks now. Now I want to go ahead and, as I said, provide a little bit of feedback to some of the comments that I received during the discussion following the last two videos that I did. That was 238 and 239. And for that, I'm going to need to zoom in down here on the workbench. Now, one of the questions that came up was why I was so adamant about using the TCS connectors like this one here, as opposed to this JST connector, which I showed in video 238. And the main reason for that is these have extremely flexible wires. You can see that, it's like a piece of wet spaghetti, and they just flip around quite easily. And because of that flexibility, I really like these, because that means that when you've got, 4, 6 wires, and they make 2, 4, and 6 wire configurations of this particular connector. And when you use those larger ones, even though you've got 4 wires or 6 wires running between your locomotives, they will still be very flexible. And they're not going to interfere with the movement of your locomotives as you go over turnouts or go around sharp curves, things of that nature. And since I use these primarily in small switchers, that is a major concern and why I like these a lot. In spite of the fact that, they do have these little exposed pins that if you drop them onto the track can cause you a short. And I don't know, maybe I went a little bit overboard in those videos with warning you about the potential damage to decoders, but I thought it was important to be able to tell you that and make you quite aware of the potential problems that you might have in using any connector that has exposed pins like that. Now with the JST, these are not anywhere near as flexible as these. You can see how flexible these are. They won't stand up straight. The JST, I can stand that up straight, not a problem. It is not very flexible. And for a 2-pin connector just going between 2 locomotives, that's probably not going to be a problem for you. Whereas you start going up to 4 wires or more, and you might run into issues with the flexibility and causing derailments as light locomotives go across turnouts and sharp curves. So that's my main argument for using the TCS wiring harnesses as opposed to using anything larger than 2-wire connectors with these JSTs. So one person said that they thought that these were available in a much smaller and more flexible wire. So my request is, if you find those, please let me know, because I would love to get some and try them out. Because I do like the JST connectors. They don't have exposed pins that are going to hit the track or anything like that. And because they are polarized, you cannot put them together in an incorrect configuration. So you're not going to have any problems with shorting on these. Whereas, as I said in the last video, you can have potential problems with these micro connectors. Okay, so that was the intent for why I promoted these to the greater extent over these. Now, another point of discussion that came up was one where an individual pointed out that another person that he knew had come up with this idea of using these connectors between locomotives to share power and sound and the like. I know for a fact that this type of method has been used since the mid-1980s. When I joined the Northern Virginia Model Railroaders Club in Vienna, Virginia, we were using connectors like this one right here. And this is one of my locomotives from that era. It has this connector that uses a header pin setup to share power between locomotives, and a dummy behind it that is carrying the receiver that powered the locomotive. And they shared power pickups on the wheels at that time. So this method goes back to at least 1990. And I subsequently wrote articles about sharing sound and using sound speakers in dummy locomotives. I wrote an article that was published in Railroad Model Craftsman about 2008 showing that technique. I wrote an article in 2016 in Model Railroader on putting speakers in 2 units and powering them with a single sound decoder. And then I wrote another one in 2018 in Model Railroader again that showed this idea of using power pickups from 2 locomotives shared through a connector like this, or one of the TCS connectors in that case. So this is a method that's been around for well over 30 years. There's nothing new about it. And there's just different iterations of it. And, I think it's great that other people have discovered the method. It's well documented in the hobby literature and in use at the Northern Virginia Model Railroaders since the late 1980s. Like they say, there's nothing brand new in the world. Somebody has always done it first. And so I don't claim this is anything that I started and developed. It's just something that I grabbed onto when I was a member of that club and have used different iterations of it in order to power my locomotives and with sound decoders, as well as CTC16 and then later DCC power. Now let's go ahead and take a look at one specific question that someone asked, and that was, what happens when you park a locomotive across the power blocks or the gaps between 2 blocks on a layout? And, that's a very good question. It's something that I've never really talked about in any of my articles, and I've never seen anyone else mention it anywhere. So I think it's a very good one to spend a little time on, because there are some important issues that you need to be aware of. Now, basically, what I'm talking about then is the blocks where you have 2 different boosters powering a section of the layout. And, this is something you would want to do if you start to get to the point where you need more than, say, 5 amps to power your layout. So you might have, in this case, I've got 2 5-amp boosters. One actually is a DCS 200 command station, and this one here is a DB150 command station booster. And they're both capable of putting out 5 amps. The DCS 200, you can actually go up to 8 amps on that. But the idea behind having 2 separate boosters to power your layout is it really allows you to operate more locomotives. It doesn't give you the, say, 10 amps. It gives you 5 amps in one area and 5 amps in another area. So basically, though, if you've got your locomotives spread out around the layout, as most of the time they will be, then 2 boosters will give you greater capability to run more locomotives. The problem is, what happens here at this point where the 2 blocks come together? Okay? Now, assuming that you've got everything wired up properly, and you've got rail A and rail A outputs on the 2 different boosters going to the same sides of the track. Okay, so in this case, this is rail A, and this one is rail A, this is rail B, and this is rail B. And it says so right here on the front of these enclosures. And that's an important consideration too. When you're wiring up your model railroad, if you flip those between different boosters, then you can get a short right here, because if rail A is connected to rail B, then that's going to be a dead short where they come together. So you want to make sure, first off, that anytime you're connecting up a new booster, if you get a short, go back and check your wiring back at the connection point, because you might have reversed those connections. Now, I hope that's clear. The real question, though, then was, what if you park a locomotive across these gaps? And here's the important part. If the voltage coming out of the boosters is the same in each block, then there's no problem at all. There will be no problem at all. You'll be able to just move right across. It's relatively safe as long as the voltages within the two blocks supplied by the boosters is the same. But what happens, though, if they are two different voltages? Well, the interesting thing about electronics is, with these components, the one with the higher voltage will push current into the one with, say, a lower voltage in order to bring it up to its voltage. So it's trying to equalize the system. So it's going to be pushing. Let's say this one is at 15 volts and this one here is at 14.5. It's going to try to charge this one up to 15 volts. And in order to do that, it's going to push current through whatever there is on the tracks that is across this block gap. And it only happens when you've got something across the gap. So if you've got a locomotive running across the model railroad and across those gaps, and it's moving, it's going to be an intermittent connection and it's not going to be an issue. However, if you stop a locomotive across these gaps, or a lighted passenger car, or a lighted caboose, or anything like that, then you have the potential for current to be flowing from this guy to this guy through the wheels and the wiring in that locomotive, or in that passenger car. And the interesting thing is, it can be up to the full amperage of what these boosters can deliver. So you could potentially have 5 amps of current flowing through the wires in your locomotive, through the wheels on your locomotive. And if it sits there for a long enough amount of time, it can damage your wheels, it can pit them, because you got 5 amps flowing through there. And 5 amps is enough to do some damage. Now, the important thing, though, is it can heat up your wires in your locomotive, your power pickups, that kind of thing, and it can melt the insulation off of them. So it's not a good idea at all to allow lighted cars and locomotives to sit across block gaps, particularly if there is a measurable difference in the voltage output from your boosters. Okay, so how do you know? Well, right off, there's a couple of easy ways to measure the track voltage. Now, obviously, one easy way is to use one of these DCC Specialties RR amp meters. So they are specifically designed for measuring the voltage output from a DCC booster. So let's turn these on. Okay, I've got these set up here on the track. I've got an insulator gap here with one of those plastic rail joiners in between. So I'm going to put this on the track, and hopefully you can see this. It's kind of hard to get it at an angle. And what it's reading on the left one there, it's 13 volts. Now on this one over here, it says 14.6 volts. So there's about a 1.5 volt difference between these two blocks. That's not good, folks. That means that if I had a passenger car or a locomotive sitting there, I would get 5 amps flowing through that through the wiring on that car or locomotive. So we need to try to minimize the difference between them. But what if you don't have one of these RR amp meters? Well, one thing that Digitrex says that you can do is take your voltmeter and put it on the DC setting, so you're getting DC voltage measurements, and then measure the voltage output here between, and I'm going to have to look around here and set this. I'm going to put my black probe on the ground contact here, which is the fourth one over. 1, 2, 3, 4, okay? So you're going to measure the voltage between rail A and rail B and ground. So if you look at 6.6 volts, and here it's 6.6 volts. So that comes up to 13.2 volts. You just measure the DC voltage between rail A and ground and rail B and ground, and that will give you the voltage for each half of the DCC signal. And then you just add the two together. So it comes up to 13.2 volts. Now let's go back over here on this one and see what it says. And again, I have to look down here and go ground. There's my ground. Okay, over here, we're at 7.7 and 7.7 volts. So that's what, 15.4 volts. So we've got 15.4 here and 13.2 there. Interestingly, it differs from what we measured with this railroad amp meter, and these are designed to give you a true measurement. Also, one thing Digitrax says in their manual is when you're making measurements like this, do it under no load. In other words, disconnect it from the track. You do not want to power locomotives or lights or anything else. So those are two different ways that you can actually measure the output. So how do you go about changing that? Well, there's a couple of different ways. You can see here on the face of these, there is a scale switch. And you can set it for HO, N, and OG. And in both cases, Digitrax has always used this. And the scale setting allows you to go with voltages of 12, 15, and 20 volts for N scale, HO scale, and O scale, and G scale. So that's one way you can do it. So like right off, I could change this one here to N scale, and let's see what we get that way. Okay. Now with this set on N scale, it's 12 volts. And remember, this one is at 13 volts. So right off, we've managed to get it down to a 1 volt difference. Now, of course, how do you change things after that? Now, with older Digitrax systems like this one here, this is the same. It's a DB150, same as this one. Right down inside of here, and I don't know if you can see this. Let's see. It's hard for me to see it. But right here, you can see this little orange device. That's a potentiometer. And you can take a screwdriver and you can set it into that little potentiometer and then give it a turn. And by doing that, you can adjust the output voltage from this device. And that's the way it was done with all of theirs up until the more recent DB and DCS 210s and 240 products. With those, there's a slightly different way that you can go about changing the voltage. Now with the NCE products, the Powerhouse Pro and some of their others like that, their boosters and the like, they have always had the little potentiometer inside the case that you could make that adjustment with. With the Power Cab and the SB5, that is not the case. With the Power Cab, it's basically a voltage follower in that the output is going to be just a little bit less than the input voltage. And with the SB5, it's controlled by the voltage of the transformer as well. And there's two settings on that. And if you look back at the video I did on the SB5, I covered that. You can select either 12 or 13.8 volts with it. But what about these newer Digitrax products? Well, again, they still have that same scale switch, and their voltages are similar. They're close to the 12, 15, and 20 volt values. I think it's something like 12.4 and 14.5 and 20 volts, something in that range. And they have a different method now that allows you to use your handheld throttle to adjust the voltage. So it's a little bit simpler. You don't have to open the case and go inside and adjust a trim pot to do that. You can simply use your handheld throttle and follow their steps. And it involves several steps, but it does allow you to adjust that voltage. And if I remember correctly, I think it'll give you a range of somewhere about 1 volt that you can adjust around. So that allows you to match boosters as well. Now, a lot of other companies, they have different ways of doing this. I think, you know, the MRCs used to be basically voltage followers. And by voltage follower, what I mean is the voltage output to the track will be close to whatever voltage you are supplying it. So that allows you to adjust the voltage by changing your transformers. But you never know in advance how closely they've got them adjusted. So I'm not 100% sure on that. Now, I don't have any experience in dealing with this issue when it comes to the various systems made by the European companies, companies like the makers of locos with their ecos system, and various others over there. So be aware of this problem and think about that when you're getting ready to purchase a booster and a power supply. Ask your dealer and read the manuals, read the information up front to find out whether or not they have a way of adjusting these voltages that are being fed out to the track. Let's say that you have an 8 amp booster like this DCS 210 or 200, and you want to use that and break your layout into several blocks. Well, as I've shown here on the Piedmont Southern, and I covered in my video on power management, I use a DCC Specialties PSX4. And what that is, it's got 4 circuit breakers built into one board, and it allows you to take the output, say an 8 amp output, and share it among 4 different blocks on your layout. That way you can spread out the amperage across your layout the same way that it's done in your household breaker box. And so it's the same concept with power management. So go ahead and take a look back at my power management video. I'll put links to that video above me here, and any others that I find that I think will be pertinent to this, I will include at the end of the video. So basically then, to wrap this up, anytime you have your layout subdivided into separate blocks and fed by 2 different boosters, you need to make sure that the output track voltage from your different boosters is as close as possible to one another as you can get. What happens though when you run into situations where you cannot get these matched because your system, your DCC system, doesn't allow you to adjust voltages? Well, in that case, what you have to do is place this rail gap somewhere on your layout where trains are not going to be stopping. So I'm on the Piedmont Southern. I have my layout subdivided into 2 sections, and each section is powered by an 8 amp booster. And I've got those adjusted as close as possible as I can get. They're zeroed out initially. But just to be safe, I also have my main gap between the 2 halves of the layout in an area between 2 towns, where locomotives are just going to go rolling right on through, and they're not going to be stopping. So there's no need for any locomotives or lighted cars to be stopped across these block gaps. And you could also put some sort of a warning sign next to the track right at that point to remind your operators and guests not to stop at that point. And that way you can do this relatively safely, because most of the time, 99.9% of the time, these 2 halves are going to be physically separated. There's no connection. The only connection that you will get between the 2 block halves or the 2 blocks is when you've got a locomotive or a passenger car or whatever sitting across those gaps. So if you have these gaps off somewhere where nobody's ever going to be stopping, it won't be a problem for you. So that's one way to handle this issue. But the best way is if you have a Digitrax system or an NCE system or another system that allows you to adjust your voltages, then that is the safest way to do it. Now that doesn't mean that if you measure it on the track, you might see small variations, because there can be losses in voltage on long runs on your layout, long wiring runs. You can also get it because of differences in the track lengths from the closest feeders, and just things like that. And also, if you've got a lot more locomotives in one half than in the other half, then that can also drop the voltage a bit. But if you've got them set so that at the boosters themselves, at the track outputs at the boosters, that there is essentially zero difference in the voltage output, then you'll be relatively safe. Well, that's a wrap for today's video. I hope that gives you a better feeling for the potential problems that you could run into when you have blocks on your layout that are powered by different boosters. So it's always a good idea. Make sure that you get those voltage differences zeroed out one way or another, whether it's NCE or Digitrax or possibly some of the other systems, and don't run into any issues. If you can't zero out those voltage differences, like I said in the video, make sure that you set up your block gaps in locations where your trains are not going to be stopping directly over them, where your locomotives will not be stopping over them, or lighted cars, because that's really the place where you're going to see the most likely issues pop up. So that's it for this week. Have a great weekend, and we'll see you here next week with another video from the DCC Guy. Bye now.